Synthetic division. This is going to be a day where we look at a nice trick that when it works mathematically, it's going to save us a lot of time and a lot of work. We're going to come up pretty soon to a situation where we're going to have to do a lot of long division, and that's going to slow us down. Synthetic division is going to be the shortcut that makes life a lot nicer for us. But before we get into division, I want to talk a bit about substitution. And the idea here is if I've got something like f of x equals 3x cubed minus 2x squared minus x minus 15. And we wanted to find maybe what f of 2 equals. Well, the way we've done this up till this point is we put 2 in for all the variables. So it would be 3 times stuff cubed minus 2 times stuff minus stuff, 2 times stuff squared, minus stuff minus 15. And we'd plug the 2 in there all the way across. So then exponents first, we would do 2 cubed, which is 8, minus 2 times 2 squared, which is 4, minus 2 minus 15. 3 times 8 is 24, minus 8 minus 2 minus 15. And then just going across, 24 minus 8 is 16, minus 2 is 14, minus 15 is negative 1. And that's not too bad to do, but I want to show you kind of a neat little trick that we can do to make this substitution easier. It's called synthetic substitution. What I do is I put a little box over here on the side where I'm going to stick the number that we want to substitute in. We're going to substitute in a 2, and I'm going to draw a line here leaving 2 lines of space above, and I'm going to put the coefficients of this problem all the way across. So it's 3, negative 2, negative 1, and negative 15. Okay? There's the setup. What we're going to start doing now is that we're going to bring this 3 straight down. And then we're going to take the 2 and we're going to multiply by what's in the bottom row. 2 times 3 is 6. And I'm going to stick that up here underneath the negative 2. Now what I'm going to want to do is I'm going to add my column straight down. Negative 2 plus 6 is 4. And then we repeat this process. We're going to multiply 2 times the 4 is 8. And when we add negative 1 plus 8 is 7. And then we multiply 2 times the 7, we get 14. And when we add negative 15 plus 14, we get negative 1. And what I want to notice is this last number we ended up with is the same number that we ended up with when we plugged in the 2. This process was probably much easier to work with, especially if we were doing a problem such as f of x equals 7x to the 5th plus 2x to the 4th minus 38x cubed minus 95x squared plus 6x minus 9. And we're going to be asked to find what f of 3 is. I really don't want to plug 3 into this long thing and work it out. It is going to be a pain. But what we can do is synthetically substitute the 3 into the problem, taking the coefficients all the way down the line. When we do, we have 7, 2, negative 38, negative 95, 6, and negative 9. Bring the 7 straight down, and then go through the process again. 7 times 3 is 21, plus 2 is 23. Multiplying by 3, 23 times 3 is 69. Minus 38 is 31. times 3 is 93. Subtracting the 95, we get negative 2. Times 3 is negative 6. Subtracting the 6, we get 0. Times 3 is 0, which brings it down to a negative 9. If we were to plug 3 into this long thing and do all the algebra arithmetic to work it out, we'd end up with negative 9. But the synthetic division made the problem much quicker for us and quite easy to handle. I'm sorry, synthetic substitution. Substitution is what we're doing here. Let's do another problem. How about this? Let's say f of x equals 3x to the 4th minus 2x squared plus 5. And we're going to find f of negative 2 this time. Before we get too far into this problem, I want to notice something that's different about this problem. This problem is missing x cubed. There's no x cubed term. It's also actually missing the x term. Anytime something is missing, we need to add 0 of it. So we're going to add 0x cubed, and we're going to add 0x to this problem as we set up the synthetic substitution. If you don't add the zeros, it will not work. So we've got the negative 2 outside, a 3, 0x cubed, negative 2x squared, 0x, and 5. Bring 3 straight down. 3 times negative 2 is negative 6. Negative 6 plus 0 is negative 6. Times 2 is 12. Minus 2 is 10. Times negative 2 is negative 20. Plus 0 is negative 20. Times negative 2 is positive 40. Plus 5 is 45. And that quick we have come up with our answer that f of negative 2 is equal to 45. So that's an important step. We don't want to forget it. It's going to catch people unaware. If you are missing a term, you need to add 0 of it for the synthetic substitution to work. It should count down. 4th power, 3rd power, 2nd power, 1st power, 0 power. It should count down. If one is missing, it won't work. Let's try another one. Let's say f of x equals x to the 4th minus 5x cubed minus 7x squared plus 29x plus 30. And we're going to find f of 5. So we stick 5 in the corner, and the coefficients are 1, negative 5, negative 7, 29, and 30. Bring the 1 down. Times 5 is 5. Minus 5 is 0. Times 5 is 0. Minus 7 is negative 7. Times 5 is negative 35. Plus 29 is 6. Negative. Times 5 is negative 30. Plus 30 is 0. So f of 5 is 0. However, this is interesting, and I want to plant here and look at this. F of 5 is 0. That means when x is equal to 5, we have a y value of 0 or an x-intercept. What this also means, if I subtract 5 from both sides of this x equals 5, x minus 5 is a factor. We should be able to factor x minus 5 out of this big thing. This big thing is x minus 5 times something. Well, let's find out what that something is. The way we get something out of there is we use long division. And you remember doing long division. We take x minus 5 and we divide it into the entire polynomial, which was, I scrolled off too fast, x to the 4th minus 5x cubed minus 7x squared plus 29x plus 30. So if we divide it out, x goes into the x to the 4th, x cubed times, we'll say 1x cubed times. Multiplying 1x cubed times x minus 5, we get x to the 4th minus 5x cubed. Changing the signs so that we can combine, we get 0. Bring down negative 7x squared. X goes into 0x cubes, 0x cubed times. Multiplying by 0 is not going to do anything, so let's just move down the next term. Plus 29x. X goes into negative 7x squared, negative 7x times. Multiplying out front, we got negative 7x squared minus 35x. Change the signs so that we can combine. Oop, I'm sorry, negative 7 times negative 5 should have been a positive 35. So when we change the sign, we get 29 minus 35x, which is negative 6x. Bring down the plus 30. X goes into negative 6x, negative 6 times. So we've got negative 6x plus 30. Change the signs, and we get 0. So we've got our solution. But what's interesting to look at here is when we had 1x cubed, that corresponded with the 1 from the synthetic substitution. The 0x, that should have been squared. Boy, I really did this wrong. The 0x squared corresponds with the 0 in the synthetic substitution. The negative 7x corresponds with the negative 7 in the substitution. The negative 6 corresponds with the negative 6. And the remainder corresponds with the solution, or the remainder. What this means is essentially substituting in 5 is the same as dividing out x minus 5. That means our synthetic substitution could also be thought of as synthetic division. Where we are going to divide out the 0. In other words, if I'm asked to find 2x cubed minus 20x squared plus 56x minus 46, and we're going to divide out x minus 6, we just need to identify the 0 that's being divided out. Make the denominator equal to 0, add 6 to both sides. That's the number that goes in the corner. We'll put the 6 in the corner and we get 2, negative 20, 56, and negative 46 for our numbers across. And this becomes our synthetic division. Bring the 2 down. 2 times 6 is 12, minus 20 is negative 8, times 6 is negative 48. Add 50 is 2, times 6 is 12, minus 46 is negative 34. To get the variables in there, we're going to drop 1 off of the x cubed, the leading coefficient, so we have x squared, x, and a constant, and the last part is the remainder. We can either say this is a remainder of negative 34, or we put the negative 34 over the denominator of x minus 6. So to clean it up, when we divide, what we get is 2x squared minus 8x plus 2 minus, because the remainder was negative, 34 over our common denominator of x minus 6. we have synthetically divided out the x minus 6. I love this method because it is so much easier than long division. Let's try another one. Let's try 2x to the 4th plus 5x squared minus 7x plus 1. And we're going to divide it, whoops, wrong color. We're going to divide it by x plus 2. To set it up, we find the 0. X plus 2 equals 0, so x equals negative 2. That's who's going in the corner. Want to be careful as we go across, though. Don't get moving too fast. You might notice we're missing the 0x cubed. Always check to see if anybody's missing. So we're going to go across. We're going to need 2. Don't forget the 0 for the x cubed, then the 5 for the x squared, the negative 7, and the 1. Don't forget the 0. Don't put it in the wrong spot. It must count down 4, 3, 2, 1, 0. Alright, so we've got 2 times negative 2 is negative 4, plus 0 is negative 4, times negative 2 is 8, plus 5 is 13, times negative 2 is negative 26, minus 7 is negative 33, times negative 2 is positive 66, and so we end up with 67. Drop the exponent by 1, so we're going to start with x cubed, x squared, x, a number followed by the remainder, which is going to go over our denominator, x plus 2. So for our final answer, 2x cubed minus 4x squared plus 13x minus 33. This time the remainder is positive, so we will add 67 over x plus 2. Let's try one more. It's going to be a lot of fun because it's going to involve fractions. Number 3, we have 3x cubed minus 4x squared plus 5, and we're going to divide by 2x minus 3. We make that equal to 0 to find our 0 that's coming out. So we add 3 and divide by 2, 3 halves. So we're going to see if 3 halves can come out. Again, did you check? Do the exponents count down? 3, 2, we're missing 0x. So we've got 3, negative 4, 0, don't miss the 0, 5. Bring the 3 down. And now we have to deal with fractions, but the idea is the same. Remember, that's 3 over 1, so 3 times 3 halves is 9 halves. To add, we'll make the 4 have a common denominator. It's going to be negative 8 halves. So negative 8 plus 9 is 1 half. Times 3 halves is going to be 3/4. 3/4 plus 0 is just 3/4. That's nice. 3/4 times 3 halves is going to be 9/8. Multiplying across, which means the 5 is going to be 48. So 9 plus 40 is 49 over 8. And again, we drop 1 down from the exponent, so we're x squared, x, and then a remainder, which is going to go over the 2x minus 3. So we have 3x squared plus 1/2 x plus 3/4 plus, because the remainder is positive and that 8 is part of the denominator, if we multiply by the reciprocal, we'll end up with 49 over 8 times 2x minus 3. And that's what we get when we do our synthetic division. Synthetic division is a real simple process, but you need to practice synthetic division. Just getting synthetic division is not going to be enough. You want to practice it so that you can run through this process fast, fast, fast. Because what we're going to do in tomorrow's lesson is we are going to be doing lots of synthetic division to solve one problem. You don't want to get bogged down on the synthetic division. You need to be fast, fast, fast at this process. You need to know what step comes next without hesitating and be able to run through it fast so that you can focus on tomorrow's lesson, which is called the rational root theorem. Practice today. We'll see you tomorrow in class. Thank you.